In the name of God, in the name of without doubt is capable and voice, welcome to your own channel. I hope all of you be healthy and fine. In this episode, we are going to design the transmission tower. First of all, you all know better that what is a transmission tower. A transmission tower, it is used to support the overhead power line. It means that for transmission of the power from one place to another place, we need the transmission tower. Okay, that this transmission tower by cables they can transmit the power from one place to another place, and it has a lot of the wide range. We need this transmission tower for television station, for radio station, for internet connection station, for electricity station. So it means that it is very important that a civil engineer should know about designation of the transmission tower. So in here we have one transmission tower, okay, that we have three port, okay, or we can say we have three port of the section, and then at the first part, if we see, we have 2.5 into 2.5 meter. It means that our width is 2.5, and if we see this transmission tower in 3D direction, or in 3D dimension, then in other side that we have the length is also 2.5 meter. Then in the second port is also 2.2 meter, and third port 1.5 1 point into 1 point meter, and the fourth port we have 1 into 1 meter. Then the elevation or the height is from 0 up to first, or we can say the second port is 1 meter, and from second port to third port is 1.5 meter, and from third port up to fourth port we have 2 meter. Then the two point load or concentrated load act on the joint load 100 kg and 100 kg, and 110 centimeter displacement act. Displacement, what does it mean? Means that the load that caused 10 centimeter displacement is act on that one. We don't know about amount of the load, that how much is amount of the load that caused 10 centimeter displacement, but we know the cause of the load, okay, or result of the load, that is 10 centimeter displacement. Then minimum yield strength of the steel that we have 3200 kg per centimeter square. Section that we should design I-beam section. So let's start. First of all, make sure with your unit, then Ctrl plus N for new page. Select the 3D truss. In here, we have, if you see, we have different type of truss, 3D truss, roof truss, transmission tower type 2, transmission tower type 3, okay, and then another type of the truss, but our type of truss is transmission tower 2. Then in here, one we have elevation, one we have the width, one we have the A, and one we have the B. What does it mean by this thing? Elevation means that how much is your height. And one thing that you should know, that we start from 0. I mean our first part should be elevation is 0. In our first part, elevation is 0 because we start from surface, and the surface elevation is actually how much? 0. In your, because at this part we don't have any elevation. In your first part, second part, third part, and fourth part. And the second one, we have the elevation of how much? From 0 up to 1 meter, because we calculate or we account from the 0. Then at the third part, our elevation is not 1.5 meter. Our elevation is 2.5 meter, and our fourth point, our elevation is 4.5 meter. Okay. Then another part that we have in here, width. Width is very easy. Width of your part, for example, here we have elevation at the first part 1, we have elevation 0 but width 2.5 meter. And the second part, we have elevation 1 but width 2 meter. Okay. Then we have the A. What does it mean, the A? A means that actually the member start from which point, member start from which distance, member start from the which height. Okay. In here, if you see, our member, as I told you, that we calculate all the member, or we consider all the member from the 0 surface, from ground surface. It means that the all value of the A in here, it should be 0. Then we have B. In B we have two value, 0 or 1. Zero means that below of your port, if you have another port or not. If you have another port, means you should put 1. If you don't have another port, you should put 0. For example, at the first port, below of the first port 1, below of the port 1, we don't have any other section. So it means that in here the value of B is 0. But in a port 2, below of the port 2, we have another section. So means this value is 1. Below of the port 3, we have another section. Means this value is 1. It means that the value of B only for first port is 0 and for rest of them is 1. But value of the A for all of them is actually 0. Okay? Why? Because we consider up to 0 elevation or 0 distance. So now for the first point, our elevation is 0 and our width is 2.5. Okay. Then A. Then we have A. We start from 0 level. So the A value is for all of them is 0. And then we have B. In here below the port 1 we don't have any other section. So we get the 0. Then for point 2, how much is our elevation? Our elevation is actually for port 2, our elevation is 1 meter, width is 2 meter, A is 0 and B is 1 because below of that port 2 we have another section. So means that it is actually B is 2, sorry, in here not, in here B is 0, in here we have, okay, elevation we have 1 meter, okay, and then width we have 2.5. A, how much A we have? A we have 0 in all cases and B is also 1. Then in third case if you see we reach up to here. Then now our elevation is 2.5 and our width is 1.5. You mean elevation 2.5 and our width is actually 1.5. Okay, then we reach, it was all about the port 3. Now we are reach up to port 4. Now our elevation is 4.5 and our width is 1. Elevation 4.5 and width is 1. One another thing that you should know, guys, that if we have the fourth port 1, 2, 3, 4, we have to get one port more. It is the rule designation in SAP software. If you have the fifth port 1, 2, 3, 4, 5, for example, suppose here we have 5, so you have to get the number of port 6. In here we have 4. Okay, so what would be the dimension of the fifth port? Same with dimension of the fourth port. Means that in here it is also 4.5 and in here also we have the 1. Okay, now it is our so now, guys, it is our transmission tower. Okay, now in this transmission tower, if you see, if we want to delete this grid line, for deleting of this grid line in our 2D portion also the grid line will be deleted. Okay, so if we want to delete edit grid data, modify show system, in here if we delete for 2D dimension also the all grid line would be deleted like this. Now what should we do in here? We have to define material concrete delete, then add new prop material. In here is steel A36. Okay, and also A36 or grade 36 or A53, every type of ASTM, American Standard Testing and Material. It's up to you that American Society of Testing and Material, not standard. Okay, American Society of Test and Material. For example, we can get A53, no problem, grade B. Okay, and then modify show material. In here we have the steel, but kilogram centimeter. In here we have 7850. Then in here we have yield stress 3200. 3300. Okay, then define section, frame section, import new property oil section, because in here if you see we have to design for oil beam and minimum yield strength 3200 kilogram per centimeter square. So sections dot pro. Okay, select all of them and sum under one name. Then add new property auto select list. Here we can change the name oil beam. Now in here if you see this if section 1, why we didn't select? Because it is depend on software section. Okay, it's not the section that we imported. Okay, now also okay. Then we have to come for load pattern, dead load, and then we have the live load. Then define load combination 1.2 add and live load 1.6 add. Then we have to assign the section, control all, come in assign frame section. In here find the I beam, apply and okay. Okay, then we have to also put the loads. Okay, one we have in this point, in this point, at this point. So come in assign join load forces. In Z we have minus 100 kg, and also at this point. Okay, at these 2 points also we have 10 centimeter displacement. And yet if you see, if it is 100 kg, because it's a 2D direction or 2D dimension or 2D surface or a biaxial, okay, is a biaxial plane, so means that 100 kg we have also have in other side. In here if we have 10 centimeter means 10 centimeter displacement we have also in other side in triaxial plane. So now in here we have to come assign join load displacement in a Z direction. We can get minus 10 centimeter. Okay, in here we have to select according to what, which thing, according to live load. Okay, because displacement in here is occur according to live load, not according to dead load. So apply and then okay. Now in here we have also 0.1, and in this point also we have the load of 100 kg. Why we put minus? Because of the direction. Now we can come in a analyze, set an analyze option, and then run analyze. Do not run according to model, because model is combination from software. We define combination of the load by ourselves. So in here we can come Sap-8 Obaidullah Ibrahim Zada. Okay, now I will show for you that what would be the displacement. The displacement will not occur according to dead load. Okay, but if we change the load according to live load, now see here we have a displacement of the 10 centimeter. Now design, so now for designation, here if you see some of our members failed. So because of this, actually we designed that we should know that the section that we select and the load that occur or the load that applied in our section, it can resist or not. So because this we designed that we should know that which section become fail. If in here you see approximately all of them is passive, okay, passive, but only here some what you can say some section or some member fail. So you can change these member. For example, for double angle section, we can change. For double channel section, we can change this. If you change them for double channel section, it will work. But let's see that how we can change. Just only those sections that fail. For example, for an instance, we can change only this member, and this member, okay, and this two. We will see for double angle that it will pass or not. So in here we can come again and define frame section. In here import new property, we can create double angle. Double channel section, if we define double channel section or import double channel, it will pass all of them. But in here I don't have the imported sections of double channel. So in that case we can go for double channel sections. Select all of them. Okay. Add new property, auto select list. The name is double angle, and here find the double channel section. Okay, it belongs to IB. Now we replace these fail members with the double angle section. If it also not works, then we replace all of the data. Okay, then we replace all of data with all of the members with the double angle. And again, if it not works, then by double channel section it will give the answer. Now okay, now it was this member. I think this member, this member, this member, and this member. There was another field member source in this side. But if this member pass, means that you know that if we select all of them, all of the fail members, all of them will be pass. So now coming at assign frame section, select in here the double, apply, and OK. Now we can analyze it. Now if you see this member actually pass, okay, these member actually pass it, these members, and these members not pass it, okay, and here also another member also fail in these parts. Before when it was all of them I section, this member was pass it, but now they are also fail. So now what should we do? We can assign all of them for double angle section, then we will see that what is the answer. So come in assign, so select all of them, assign frame section and double angle. Now first we have to do analyze, and then design. If you see now a little bit sections are failed, Okay, only in these spots are filled. So now if we replace them for I section, okay, for example this member, so here is in these two member in all the four port. Okay, if we replace them for channel section or I section, or we can say channel section, no problem. Okay, we can camp first. We assign for I section. Now we can see that what would be the answer. Now it see it not work because another members also failed. So now we actually replace with the all of them with angle section, but only the fail one, these four with the channel section. Okay, and if you provide all of them with double channel section, it will be passed. But in here I don't have rid of the channel section. I have only one section of channel section and finish. So now in here what we can do, we can assign all of them with the double angle. Okay, but only these four one, I think this was the fail one. Okay, come in a, now we can come 40 point. We can select the channel section. So now in here we have to find the channel section. Now come in as sign, frame section and channel section. No, it not pass it. So no problem. If we go with double channel section, it will pass. Okay, only we have these four one. So like this we can do the designation. I hope you got something. Have a nice time. Got